Hey there, Ravens. We're here to talk about precipitation reactions today. A precipitation reaction is simply a reaction in which a solid is formed from a solution. So two aqueous solutions mixed together forming a precipitate. When we say precipitate, we are referring to a solid substance that is insoluble in water. So keep those words in mind, that those things are all synonyms, okay? A solid is a precipitate that is insoluble in water. All right, all precipitation reactions are double replacement reactions. One of the products of a precipitation reaction will always be an insoluble solid that precipitates out a solution. If a precipitate doesn't form, then the reaction doesn't occur. The other product is going to remain an aqueous solution. All right, so in order to be able to talk about precipitation reactions, you need to be able to predict what the products are going to be. That's like just a standard kind of thing. If I have these two substances over here, right, and I can talk about sodium hydroxide and calcium chloride, these two substances as aqueous solutions, when they get mixed together, the ions are going to rearrange themselves. Remember, double replacement is our square dancing reaction. We do a little do-si-do. All right, let me pull up my pen here. Come on. Okay, pen. All right, there we go. So now when we do a little do-si-do, sodium is going to come over here and hang out with chlorine. And then we go back in our do-si-do, calcium is going to get together with hydroxide. Now, whenever we're making compounds, we always must follow the rule of zero. Never forget the rule of zero when you're putting things together to get their formula. Pull out your periodic table to help you remember. Sodium has a +1 charge. Hydroxide has a -1 charge. There's one of each. That follows the rule of zero. Just a review for you. Calcium, being in group 2, has a charge of +2. Chlorine, in group 17, has a charge of -1, but there's two of them there, so 2 times a -1 is a -2, which combines with a +2 to equal 0. Okay, review over. Now let's put things together and make our compounds. So sodium is going to get together with chlorine, and test your rule of zero. Sodium's a +1, chlorine is a -1, we're good. Next compound, calcium. Remember, the positive always comes first. Calcium is going to get together with hydroxide. Calcium has a charge of +2, and hydroxide has a charge of -1. So in this case, rule of zero is not working. So in order to fix that, you're going to have 2 hydroxides. Okay? When we do that, we equal 0. So to make that happen in our formula, we need parentheses around our polyatomic and the 2 on the outside, meaning that we need 2 of this whole grouping. All right, last step, balance it. 1 sodium on the reactant, 1 sodium on this side. 1 hydroxide on this side of the arrow, 2 hydroxides on this side of the arrow. To fix that, you're going to have to put a 2 in front of the sodium hydroxide. That fixes the hydroxides. The sodiums, though, we have 2 sodiums, so we need a 2 here. When we do that, we have 2 chlorines. Going back to the other side, 2 chlorines. We're good to go. Calcium and calcium, 1 each. Excellent. Done. Easy? You try it. Pause the video. All right, welcome back. We are going to do the next 2. All right, so copper is going to come together with carbonate, and ammonium is going to come together with bromine. Copper, transition metal, I got to do bromine first. Bromine's a -1. There are 2 of them, so that means copper is a +2. Ammonium, NH4, is on our polyatomic ion chart, and it has a charge of +1. Carbonate, also a PAI on the back, and it has a charge of -2. Putting things together, copper and carbonate, so CuCO3, copper has a charge of +2. Carbonate is a -2. Rule of 0 has been accomplished, and we're done. Moving on to the next one, NH4 coming together with Br. So we got NH4, Br. Okay. NH4, ammonium, rule of 0, that's a +1, and bromine is a -1. We are all set. Rule of 0 has been met on both. Final step, balance it. 1 copper, 1 copper. 1 carbonate, 1 carbonate. 2 bromines, only 1 bromine. Must put 2 in front. That gives me 2 ammoniums. But oh look, I have a 2 right here. 2 ammoniums. That's done. Alright, if you haven't done the third one, pause the video. If not, we're going to go start right it now. Alright, so potassium is going to square dance and join up with nitrate. And iron is then going to turn around and join up with the sulfate. Charges, potassium's in group 1. It has a +1 charge. Sulfate, polyatomic ion chart, has a charge of -2. Iron, transition metal. Do the -1 first. Nitrate is a -1, but there's 3 of them. 3 times a -1 is -3. So therefore, iron must be a +3 because all compounds must follow the rule of 0. I can't say that enough. Okay, so let's start writing our compounds. Potassium and nitrate come together. So that's KNO3. And following the rule of 0, potassium is a +1, nitrate is a -1. Okay, and then that fits the rule of 0. Next we have iron. Remember, positive always written first. And sulfate. Alright, this one's a little more challenging. Did you get it right? I hope so. Iron has a charge of +3. Sulfate is a -2. If it's going to equal 0, we're going to have 3 of these, and we're going to need to have 2 of these. So to get that to work, that means the 2 goes down here with the iron, because I need 2 irons, and I need 3 sulfates. But I can't just write the 3 down there. See how weird that looks? It needs parentheses, because I need 3 of the entire group. Okay, so now we got to balance things. Fe2, I have 2 of them here. I only have 1 here. So put 2 there. That gives me 2 times the 3 be 6 nitrates. Only 1 over here. So gotta put a 6 there. That gives me 6 potassiums. There's 2 here to begin with. So 2 times what gives me 6? That's 3. Put the 3 there. That gives me 3 sulfates, but I got 3 sulfates there. Done. Alright, so that is it for part 1 of precipitation reactions. You are now able to predict the products and balance the equations. If you need to, watch the video again. Part 2 coming up next. See you soon.